Hey guys, it's Andrew here from Seemu Apps, and today we're going to train our custom core ML model to recognize images of animals, and we are going to train it with a cat, a dolphin, and an emu. So by the end of this tutorial, you'll be able to train your own custom core ML models with whatever images you want to recognize anything you want. So let's get into it. Okay, so let's get into creating a custom core ML model. There are two parts to this tutorial. The first part is creating and training the model in Python and exporting it as a core ML file. Then the second part is grabbing that file and actually using it in an iOS app. So first of all, let's make our model. You will need Python 2.7 installed, and there are many tutorials out there on how to install this if needed. Installing this will also install pip, the Python package manager, as we will now use this to install Cheery Create, which is an easy to use machine learning library. So what you'll want to do is in terminal go pip install Cheery Create. Press enter and that will run through the installation. It might take a couple of minutes. I already have it installed on my system. So once you have that installed, you need to create a new Python file called classifier.py and then open it up in your favorite text editor. I'm using Visual Studio Code because I really like it, and it also allows me to run Python. If you go to the debugger thing here on the left, I can go to Python. I've got a lot of different versions installed, but if you use it, you can select the default version you have installed, 2.7, then hit run to execute your code straight out of Visual Studio Code. Pretty handy. Alright, so let's train our model. And just before we get into training our model, in the description below, you can download these images. So you can see I've got some images of some cats here for training it to recognize cats. Then I have a folder full of dolphin images. As you can see now, scrolling through, they're all different dolphin images. And finally, we have a lot of images of emus. So remember to download in the description below because we're going to train our core ML model using these images. So we'll be able to recognize either a cat, a dolphin, or an emu. Let's go back to the Python file. Now to code it up, we need to do import Cheery create as Cheery. Just Cheery. Then we're going to do my path equals dataset. And the reason for that is in here we have our classifier.py file, and we're going to put all these images in a dataset file which is at the same level as its classifier.py. So that's how it knows where to grab these images from. Then we're going to do data equals Cheery dot image underscore analysis dot load images, and in the brackets we're going to do my path comma with underscore path is equal to true and recursive is equal to true. Then we're going to do data, do animals, in square brackets and apostrophes, equals data, and I'll do the path, dot apply, and we're going to apply a lambda path. And in here we're going to do cat, if cat, else in path, then we do else emu. So at the moment, we're only going to train it on cats and emus initially. And essentially what this is doing, it's going to the dataset folder here. If there's a folder named cat, we're going to tag it as a cat. Otherwise, we're going to tag the image as an emu. So what I'll do here, I'll just move the dolphin folder out for now, so we only have cats and emu. So that way the dolphin doesn't accidentally get trained as an emu, as that's the default case. Then we're going to print data.group by, I'll do animals, comma, I'll do the square brackets. In these square brackets, we are going to do chiri.aggregate.count. Then we are going to do data.save, do animals.sframe. So we're going to actually save the data. Then we're going to do data.explore. Alright, so this is our initial batch of machine learning code. So let's go ahead and run that now and see what happens. So I'll click the green run button in Visual Studio Code, and then you'll see it starts the debugger. It doesn't execute it immediately. This way you can put in breakpoints, run the code line by line, and so on. So to start it again, just go continue, and this will run the code for us. And when Visual Studio Code is running the code, it will have the orange bar down here. Okay, and you have to be quite careful with coding with Python because it's quite easy to get errors. The editor doesn't tell you straight away. So this chiri.aggregate.count should be uppercase count. So save that file, then let's run it again. Okay, excellent. Our code's run and we see this chiri create visualization come up here. And essentially what this does, this is a visualizer of what we've tagged our images as. So we can see this one here is tagged as a cat under animals. This one's a cat, and if we scroll down, we find our emus. Let's hover over it, still loading, but we can see the small icon here is of an emu. So it's tagging those as an emu. And we've done this print here of data.group by. And essentially what that does is it prints out this table here to show us our animals and how many images we have of each. So we have 53 images of emus and 34 images of cats. So this hasn't actually saved our model yet. This is only the tagging of the images. Next up, what we're going to do is we're going to actually train the model. So this is essentially setting up the data for us to train that model. So to train that model, what we need to do is we'll just comment out that data explore. That way, if you want to see this visualizer again, you can just uncomment it. To actually train the data, we do train underscore data underscore test, comma test underscore data equals data.random underscore split, and we'll do 0.9. So basically with machine learning, in order to train it, you have what's known as a golden data set. And a golden data set is essentially those images here that you know exactly what they are. So we know this is a cat, for example. This is a cat. And what this line here is doing, this trained data is going to have 90% of these images with a tag here already known. This test data, this 0.9, which is 90%, we're actually going to grab 10% of these images randomly, put them into their own pile, and not have this tag here of what animal they are. And essentially, we're going to train it to guess what those images are, and it will get better and better and improve its accuracy as we train it, up to a certain limit, of course. And this is a data set which we don't know what is. We're just feeding it into our machine learning and it will guess what the image is. So essentially, we're taking this pile of images, grabbing 90% of them with the correct tag that we know what it is. The other 10%, we try and guess what it is in order to train our model. So now that we've done this, to train the model, do model equals cheery.image underscore classifier dot create. We're going to feed it our training data, and the target is going to be animals. Then we'll do predictions equals model dot predict, and we're going to feed our test data to the model and actually try and predict what the test data is. And then we'll do metrics equals model dot evaluate, and we'll do test underscore data. And finally, we'll print out our metrics, and we're going to print out the accuracy. Okay, so this bit here is actually training our model. Then we're going to print out the accuracy of our guesses on the test data, which is 10% of those images. So let's run that now and see what sort of accuracy our model has. Now this is quite a small model. We don't have a lot of images. As you increase the amount of images, actually training it can start taking longer and longer. It can take 5 minutes with 500 images. It could take an hour with, say, 10,000 images. Machine learning is a processor intensive thing. So just if it's taking a while to run, don't be afraid. I'm running mine on a MacBook Air, and this can take a few minutes at times. So don't worry about it. Just let it run. Go have a coffee. Use it as an excuse to have a break. If you're working machine learning, perfect. You can tell your boss, oh, I'm training my model, and go have a break. So here we go. It's completed the training here. And we can see here, initially the accuracy on our images for the test data is only 62%, 0.62. Then it's 84%, then it's 100%. So it's guessing them right every time. So just keep in mind, if it's 100%, it doesn't mean if you then put it in an app and give it a weird image of an emu that it's going to guess that it's an emu. It only means our test data has been guessed correctly 100% of the time. So this is why when you're actually training a model, you want a lot of images. It will enable your model to be more accurate. And also you want a decent amount of test data to actually get a good indication of the accuracy. I mean, if you're only training it with 1 images, say you have only 10 images and 10% is the test data, that's not going to be a very good indicator of how accurate your model is. So that's actually training it. Now, how do we get it to be a core ML model that iOS can understand? Well, that's quite simple actually. What we'll do here, we'll print out saving model. Then we'll do model.save, and we're going to do animals.model. We're going to save it as a normal model. Then we're going to do print saving core ML model. We'll do model.export core ML, and we're going to export the model as animals.ml model. Then we'll print out done at the end. And the reason, and we'll save that and run it. And the reason I add those print line statements, as this saving of the model can take quite some time. So I personally like to know that my computer hasn't frozen and it's actually getting through the tasks I've coded. So I'm going to let it run now, probably take a few minutes. I'll fast forward to when it's actually saved those models. And at the end of it, we can grab this animals.ml model and jump into our iOS app, and we'll start coding it up, get that all connected and working, And then we'll come back and train the dolphins as well after we've got our iOS app going. Alright, so we can see our ML model has been saved, so we can use this with iOS now and Core ML. It took my computer about 5 minutes to actually save that, so just keep that in mind when you're saving yours. Alright, so now we've got a new single view application called Core ML custom model here. So what you want to do, first of all, grab the animals.ml model file, drag it in your project. Be sure in the destination to select copy items if needed, and then hit finish. Then head over to your main.storyboard and let's get our app set up. So we'll want an image view to actually display the image we're trying to guess as to what it is. Then we'll want some text. So sorry, a label. Drag that onto here. Make that the width pretty much the full screen. Going to center the alignment and we'll do pick an image for the label itself. Then we're going to add a button called choose from photos. So you can choose an image from your photo gallery, and I'll show you how to upload a photo later from your camera. Then go to the assistant editor, and we'll want to, using the control key above view did load, let's add this as image guess as an outlet. And for the pick an image, we'll add that as label guess. And we'll change that later on as to what our animals model has guessed the images. And then you choose from photos, connect that up as an action, and we're going to name the action take photo. Cool, we've got our boilerplate code set up. So let's close down the assistant editor, go to our view controller and start coding it up. So under import UI kit, we'll do imports core ML, and we're going to import vision as well, as we're going to use core ML and vision to guess what the image is. Then after UI view controller, we want to do a comma and add on the protocols UI image picker controller delegate, and don't forget the delegate part, and UI navigation controller delegate as well. And this is going to let us pick an image from our photos app. So in order to do that, in take photo, we'll do if UI image picker controller dot is source type available, and in the source type we're going to do UI image picker controller source type, image picker controller source type, and we're going to do dot photo library. So this is going to take a photo from our photos library, and then if it is available, we'll do let image picker equals UI image picker controller, do image picker dot delegate, and we'll delegate the self, so this view controller to be the delegate, do image picker dot source type. I'm going to do UI image picker controller source type dot photo library. Then we're going to do image picker dot allows editing, and we're going to set it to false. We don't want them to edit their photos on the fly. We'll do self dot present. We're going to present the image picker controller, do animated as true, And for the completion handler, we're going to do nothing. So nil. We'll save that. So what this is going to do here is essentially we open up the user's photo library and then present that to the user. So when they actually select an image from the photo library, since we have a UI picker controller delegate, UI image picker controller delegate, and a UI navigation controller delegate, if we start typing here did finish picking media with info, we can see we've got this autocomplete for our function here. So just select that. And when the user either selects a photo from the gallery or the camera later on, this code will be run. Once they tap on it, it will close it down, come back to our app and fire off this code here. And this is where it's actually going to guess what's in the photo, whether it's an emu or a cat. So for our label guess, we'll set the text to thinking, as it takes a while to think, just a few seconds, but we don't want the user to think the app's frozen or anything like that. Then we're going to set the image view. So do image guess dot content mode. So it's image guess dot content mode. Going to set the content mode to be dot scale to fill. I'll do image guess dot image, and we're going to set the image to be the picked image. And just above this label guess thinking here, we're going to add if let picked image equals info. In the square brackets, we're going to use UI image picker controller original image. So we're going to grab the original image and we'll do as question mark UI image. And we'll move this code to inside this if let statement. So this is picked image is the user the image has picked. Then we set our image view to actually be that image. Then we need to get the model. So we'll do get the model. So do guard let model equals try question mark VN core ML model. Do brackets. We'll do for, and we're going to do animals brackets dot model. Do else, and in this else we'll do fatal error, and we'll pass a fatal error unexpected results. So this is going to open up our animals model here that we've trained. Next of all, we need to create a vision request. So to do that, we'll do let request equals VN core ML request. And the model is going to be the model. So model colon model. And then do curly brackets in here. We'll do square brackets weak self. Space request, comma error in. Then we'll do a new line. And that's not error info, that's error in. So make sure the autocomplete doesn't add on info. We'll do guard let results equals request dot results as question mark brackets VN classification observation square brackets comma let top results equal results dot first, and we'll do else, and in this else we're going to throw a fatal error if there are no results. So do fatal error unexpected results. And just going up to just get the model fader error here, this is actually meant to say unable to load model. I got a bit too far ahead of myself there. Alright, cool. So after this, we'll want to update the main UI thread with our result. So to do that, we'll do dispatch queue .main.async, and in this async we're going to add a square bracket week self square brackets in as well, and then in this code we'll do self question mark dot label guess dot text, and in here we'll do equals, and we're going to do backslash top result dot identifier with, and we'll do backslash, and we'll do int brackets top result dot confidence times 100 brackets percent confidence. Okay, so that was a bit of a block of code, wasn't it? So this is creating a vision request. It doesn't actually fire it off straight away. It's just creating a request. Next to the while, we'll actually run the classifier, which will use this request. And when this runs, essentially, these results will be the guesses for what the image is. If there are no results, we'll just do a fatal error. If there is a result, we'll grab the top result, and then since this is a request, we need to update the main UI thread on a dispatch queue. And if you're not too sure what that is, you can check out the tutorial in the description below. And essentially, we're updating our label with the top result identifier with the percentage of confidence it has. So say we upload an image of an emu, and it's only 60% sure it's an emu, it will show emu with 60% confidence. So now, under here, what we need to do guard let ci image equals ci image down here, and we'll do image as picked image. Else we'll do a fatal error. So fatal error, and in the fatal error we'll do cannot read picked image, because our core ML model needs a CI image type instead of a UI image type. So it's a core image type. Then we just need to run the classifier. So in order to do this, we'll do let handler equals v and image request handler. And we need to pass in a CI image. So we're going to pass in the CI image we had before. We don't need to pass in any options, so just ignore that. Then we'll do dispatch queue dot global dot asynchronous request. And in here we'll do, and we'll do try handler dot perform, and we'll try and perform the request in square brackets. Else, catch, we'll do print error. So essentially we create a handler with our image, and we need to do handler.perform, and we perform the request we created here, which is a vision request, and our image, our CI image, is passed through this handler. So essentially our request automatically grabs that image and will try and determine what the image is. If it can't do it, it will print out the error. So let's run that on an iPhone 8 now to see that in action. We can see our first model working in an iOS app. So that's pretty cool, isn't it? We have our own custom model right now, right here. All right. So we got pick and image here. So it should be pick and image. Anyhow, we'll go to choose from photos. And I've already grabbed some photos here of a cat, an emu, and a dolphin from Google Images. So since we only have a cat and emu, I'll select a cat here. Okay, so I just noticed a small oversight, and essentially what that is we forgot to actually dismiss this image picker controller. So in our image picker controller, did finish picking media with info. Just right at the very end, we need to do picker.dismiss and do animated as true and the completion handler as nothing. And then we'll rerun that now and we'll be able to actually select our image properly and we'll go back to our app. Okay, so let's go to choose from photos. We'll go to our camera roll. We select the cat, it's thinking. It knows it's a cat with 99% confidence. Go to choose from photos, we'll go select our emu. It goes thinking. It's an emu with 99% confidence. And just a quick note here, if you actually go through the images in our data set, say of our emu, we'll scroll through them here and we'll notice not one of these images is actually of the emu we uploaded. They're all completely different emus. So it has never seen an image of this particular emu before, and it's being able to guess it's an emu with 99% confidence, or from our custom model with a bunch of emu images right here, right now. So if we go back to choose from photos, let's see what happens if we select something completely different, like a dolphin, which we haven't trained for yet. So it thinks a dolphin is currently a cat with 92% confidence. We go back and select, say, a waterfall. It thinks it's a cat with 82% confidence. So this is the thing you have to be mindful of. Whatever your model has, it's going to pick the top result that it thinks the image is of. So you want to check this confidence rating, and if it's not that confidence, your image is of a cat, then you probably want to show something else to the user or take a different course of action. So just keep that in mind when making your own custom models. Okay, so what I'm going to do from here on, we're going to train our dolphin images, add them into the app, and make it so the user can actually load an image from their camera so they can take a photo. So let's go back to Python to train our dolphin image. So going back to Python, to train our dolphin image, we're going to go back to our Finder, add the dolphin back to our data set. And in here, we have this line here, which is essentially categorizing our cat and emu. So how do we add a dolphin to this if it's just an if-else statement? What we need to do, we need to create a custom function. So we'll do define def get image from path, and we'll pass in the path to our function. And in here, we'll do if it's a cat in path, want to return a cat. If it's an emu in the path, we do return emu. If it's a dolphin in the path, so dolphin in path, and emu is meant to have in path and colon as well. We'll return dolphin. And by default, we'll return a cat if we don't know what it is exactly. Then in this lambda function here, we simply get rid of this and we call our get image from path, and we pass in our path, and that's it. So let's comment out the bottom half of this code and uncomment out the data.explore, and we'll just run that here to actually make sure it's getting the images of our dolphin. And we're using data.explore just so we can visualize it, make sure the dolphin images are right there. Okay, so running that code now, and we can see for some reason it thinks our dolphins are emus, which is pretty strange, am I right? There's actually a good reason behind this. If we go to Finder and go to our path, this path is our whole path here to our YouTube tutorials folder. So along that path, I have a folder called, we'll just make a comment here, called Seemu apps / YouTube tutorials, say / core ML as an example. And in here, we'll have one called Python, and we'll have our data sets. And this is going to have our folders called cat, dolphin, emu, and so on. So essentially, this if statement is checking the whole path here, and if emu is in the path, it's going to return emu. So there's an emu in Seemu apps, so that's why it thinks the dolphin is an emu. And the cat, we got lucky, it found the cat folder first, so it starts from down here and goes up. So if I swap out emu to be under dolphin and delete that and run that now, let's see what happens. So this if statement is going to go from the top to the bottom. So first of all, it looks for cat. If it can't find cat, it will look for dolphin. Otherwise, it will look for emu. So now we can see it actually classifies the dolphins correctly. So this is all well and good, but as you see, that's a pretty major pitfall if our folder contains a part of the name we are looking for. And not only that, what if we had 100 animals? Do you really want to code out 100 if statements? Say if dog, if bird, if bin chicken, if cow, and so on for 500 or 100 animals? No, that's absolutely insane. That's not why we program, right? So let's get rid of this and make it a lot more better to be able to automatically pick up the folder it's coming from. So we want to do import OS for that. And then in its get image from path, what we're going to do, we're going to do return os.path.base name. I'll do brackets os.path.dir name for directory name. And then we'll do os.path.path norm path. That's it. Close off all those brackets here nicely. So we've got 3 on the right hand side, and now run that. And let's see it classify our images. And we need to get rid of one of these brackets, so it's actually 2 on the right hand side. So let's run that now. And we'll make sure it actually classifies our images correctly. For fuck's sake, you piece of fucking shit. And in norm path, we'll make sure we include a bracket path here. So we pass in the actual path, which is the whole path to our folder. So let's run that now. And this needs to be 3 brackets on the right hand side. We will rerun that and we'll make sure it actually classifies our images correctly. Then I'll explain what this ridiculous thing is of several OS paths chained together actually does. Cool. So we can see we have our cats correctly, our dolphins, and our emu. So we've got an emu here. And there'll be more emus elsewhere. Let's see. They're all hiding away. So we've got 152 rows. It only shows up to row 99. So if we go row 110, doesn't seem to find it. But anyhow, it's actually there. We can see here we have 53 emus, 65 dolphins, and 34 cats from printing out the count of each item. So essentially what that line of code here does is whatever the folder name is, it will tag the images in that folder as that category. And to break down this line of code, the norm path here, so the norm path will normalize a path. So it will strip any weird slashes and anything like that. So say our path is A, B, and C, and we have a folder called cat. And in that folder called cat, we have an image called meow1.png. That's what our path will initially be in our norm path. Then in this ospath.dir name here, so directory name, so dir name, this will return the directories only. So essentially, it grabs all these folders up here, gets rid of the file name, and just returns that. So the path to our cats folder. Then, finally, the last one, which is the os.path.base name. The base name will return the first item on the right here, so the base name. So whether that be a folder or file, it's going to return the base of the path. So this is going to simply just return cat, and that will return the cat folder, apply the cat label to it because the folder is called cat when it returns that. So that's how it can automatically tag your images based on the name of the folder. So now if we had 100 images of animals, we wouldn't have to create a case statement and specify each one. It can automatically figure it out from the folder name. So that's pretty neat. So now that we've verified that, we'll comment out our data explorer, uncomment out the rest of your code. So in Python, that's a hashtag. Hit the run button, and we're going to train our model to now include the dolphin. So let's just let that run through. Now that we're training a dolphin as well, it's going to take longer because there's more images. So I'm going to speed mine up because it takes about 5 minutes on my MacBook Air. Okay, cool. So our new core ML model has saved. So all you need to do is you need to go back to Xcode and we'll delete our old model. So right click, go delete. We'll move it to trash. Come back to Finder grab our newly minted model. See, it's 94 megs here, so these can get quite big, so keep that in mind. Copy that across. Now let's run that now and check out what happens if we add a dolphin to see if it will actually guess if it's a dolphin or not. So go to choose from photos, camera roll, dolphin, thinking. Boom, we have a dolphin with 98% confidence. So now we've also trained our model to detect dolphins. So now you know how to add in any image you want with any amount of types. So that's pretty easy now, isn't it? Once you've got it set up once, you can just run this code as many times as you want. And you can change the path to be dataset to be something completely different if you want to run the same code for a different model. Now, one more final thing. If we go to our main storyboard, we can go button, we can do take photo here. And this will be taking a photo from the camera. Let's go to our assistant editor and connect it up. We'll name the function take photo from camera. So take photo from camera as an action. Connect that up. And going back to our view controller, this one's actually quite easy. It's pretty much the same as our take photo from images. So copy this code into that new function. And all we need to do is we need to change this .photo library to .camera. We'll change this one to .camera as well. And now we're done. So you can't actually use the camera on a simulator, but if you were to run this on an iPhone now and tap that take photo from camera button, it's going to use the camera on the iPhone to take a photo. So if you were out looking at cats, you could take a photo of a cat straight from the camera, and then the app can detect if the image is indeed of a cat. Because you might be blind, you might for some reason think a dog is a cat. Maybe the dog looks like a cat, who knows? Alright, you can download the source code for this in the description below. Be sure to give me a like, hit that subscribe button. If you have any comments, leave them below. I'll see you guys next time.